Hello everyone. Thank you for joining another event for Data in Greece. Today we have an exciting new presentation for you. This will be Delta live tables. And today, please do not be afraid. This will not be just a PowerPoint presentation. We will have an exciting demo for you as well. So without further ado, let me please introduce Apostolos Athanasiou, who's a senior data engineer. He has several years of experience working with data in international projects. He's certified in cutting-edge technologies, and he will be leading the show today. So Apostolos, thank you very much for joining. The floor is yours.
Apostle, thank you for the introduction, much appreciated. Hello everyone, thank you for joining today. We have prepared a very interesting presentation and demo, and hopefully you will find it very insightful and useful on a practical level. We are going to see how to ingest streaming data from an IoT device and build a Delta Lake from scratch in Databricks using Delta Live tables. First, we are going to see briefly the history of the Delta table, of the Delta Lake, then the Medallion architecture, and then we are going to move on to Delta Live tables. We are going to see what Delta Live tables are, what datasets we have in Delta Live tables, the ingestion sources, and the benefits of using Delta Live tables. At the end, we have prepared a very interesting demo, so stay tuned till the end because this is where the whole concept of Delta Live tables materializes on a practical level. So before the Delta Lake, we had the data lake, and before the data lake, we had the traditional data warehouses. I assume most of you are familiar with traditional data warehouses because it wasn't that far in the past. And although traditional data warehouses had a lot of advantages, like supporting ACID transactions, good data governance and security, and the performance was pretty high, they had limitations like not supporting unstructured data. They didn't support multiple data formats, and scalability was very expensive. Also, we couldn't access the data only by using SQL. Problems that were solved with the data lake. Data lake supported all sorts of data formats. They supported unstructured data, audio data, video data. They supported multiple languages like SQL, R, and Python. And scalability was a lot less expensive than in a data warehouse. However, data lakes also uh, had limitations like they didn't support ACID transactions, resulting to low data quality. The data governance and data security wasn't the best, and performance was relatively low. So we needed a new solution, and a solution that could combine the best of a data warehouse and the best of a data lake. And that could be the Delta Lake. Now, Delta Lake is an open source storage layer that sits on top of data lakes and brings reliability to data lakes by adding a transactional storage layer on top of the data. So by adding this additional transactional layer, now we can support ACID transactions, we have data versioning, and we have also rollback capabilities. We can time travel between different versions of the data, and we can restore the data to previous versions, which is very, very convenient. Delta Lakes can also handle both batch and streaming data in a unified way. Okay, so we have this amazing Delta Lake that gets the best of a data warehouse and a data lake, and with all those amazing features. So what's next? Next is the Medallion architecture. Now, the Medallion architecture is the recommended architecture on the cloud. The hallmark of this architecture is that it has three layers: the bronze layer, the silver layer, and the gold layer. On the bronze layer, we ingest the data as it comes. We don't perform any transformations or any changes. We just dump the data as it comes from the source. And we try to keep as much data as possible. The reason is if something happens downstream, we can come back to the bronze layer and re-ingest the data. On the serial layer, we try to have the cleansed data after performing data quality checks and transformations, and this is where we usually build our data model. On the gold layer, we have the aggregated views, where the business users utilize in order to build their reports. Now, we can have different sources. As you can see on the left-hand side, we have Kafka, SQL Server, Amazon Kinesis, JSON, CSV, TXT files. And on the right-hand side, you can see as consumers, we can have Stream Analytics, Power BI, and other reporting and data science tools. On a more detailed level, we can say that the bronze layer represents the unprocessed history of the data. We capture the provenance of the data without parsing or making any changes. It should be append only, whether it's batch or streaming, and we try to, as we said, retain as much data as possible to keep as much history as we can. Now, on the serial layer, we try to preserve the grain of the original data without performing any aggregations. We try to eliminate duplicate records. We try to enforce the schema, perform data quality checks, quarantine corrupt data, and this is where we build our enterprise data model. And on the gold layer, as we mentioned, we try to have the enriched aggregated views for the business users, and this is where we have our star schemas and data marts for the BI queries. Okay, so now that we have a basic understanding of a Delta Lake and of the Medallion architecture, let's move on to the Delta Live tables. Delta Live tables is a declarative ETL framework for building reliable end-to-end data pipelines. Now, at this point, I expect someone to ask, okay, what is the difference between a Delta table and a Delta Live table? The difference is that the Delta table is a way to store data in tables in Delta format, whereas Delta Live tables is a framework that creates, maintains, and keep Delta tables up to date. Delta Live tables allow you to describe how the data flows between these tables. I know Delta Live tables is a confusing term, but keep in mind here that a Delta Live table is a framework, so completely different things. When it comes to datasets, to Delta Live tables datasets, we have three types. The streaming table, each record is processed exactly once. This assumes an append-only source. We have the materialized views, where the records are processed as required to return accurate results for the current data state. Materialized views should be used for data sources with updates, deletions, aggregations, or capture data change data. And then we have the normal views, where the records are processed each time the view is queried. We utilize views for intermediate transformations and data quality checks. When it comes to Delta Live table sources, when it comes and cloud object storage, we can use Amazon S3, Azure Data Lake Storage, Databricks file system or DBFS, and we can also combine Delta Live tables with the autoloader feature, which means that we can perform incremental loads. When it comes to streaming data, we can use Kafka as an ingestion source, we can use Azure IoT Hub and Event Hub, apparently other streaming technologies as well. And we can also get data from databases like SQL Server, Azure SQL Database, PostgreSQL, and so on and so forth. Now, to the main point, what are the benefits of using Delta Live tables? Delta Live tables is a simple declarative SQL and Python framework. It helps data engineers to emphasize more on data transformations and applying business logic rather than working on error handling and data recovery. We have effective, continuous, and scheduled data ingestion. As we mentioned, we can combine Delta Live tables with the autoloader feature, so we can incrementally and efficiently load the data into the Delta Lake. We can also infer the schema since we are using the autoloader feature, and it supports schema evolution. One of the main benefits of Delta Live tables, and I would say the main benefit, is the pipeline visibility. We have the graphical representation of the data pipeline. We can see the data moving from one layer to another. We can visualize the journey of the data from the bronze layer to the serial layer to the gold layer. We have data lineage and traceability. We capture the provenance of the data. We have the origin of the data. We capture the dependencies between the tables, and we can witness real-time data flowing between the layers. And this data lineage graph, it's generated automatically based on the table dependencies in the pipeline. So we don't have to do anything. It's generated automatically. Also, we have statistics and metrics for every table, like the number of records written, the schema, data quality checks, and some other features you will see later on the demo. And last but not least, Delta Live tables also support change data feed, or CDF. Now, to give you a bit of a background here, CDC, which stands for Capture Data Change, is the process of propagating the data from the original table to the next table and or the next layer. So we want, if we perform an update in the original table or a deletion, we want those changes to be reflected to the next layer. As you can see now, um, actually CDF, change data feed, takes CDC a step further. What that means is that we don't have to write complex merge statements. So it makes the whole process even simpler. Now, as you can see on the left-hand side, we have the original table with 3 records. Let's say we update record A2, we delete record A3, and we insert record A4. Those changes will be reflected on the change data feed output. You can see we have the pre-image record, which means that we have the value before the update. We have the post-image record, which is the value after the update. We have the deleted record, and we have the newly inserted record. So all these changes are captured in this change data feed output, which is very convenient to use later on. And as an added bonus, when we use Delta Live tables support slowly changing dimension of type 1 and type 2. This is very important because many times the business users want the historical data. They want to compare old data with new data or query the data between certain time ranges. And that's why it's very important to support slowly changing dimension of type 2. And we don't have to do anything. It's out of the box feature here when it comes to Delta Live tables. Now, again, someone could ask here, why should we use Delta Live tables when we can achieve the same thing using Spark and Delta tables on Databricks? As we said, Delta Live tables is a framework, and these 3 are the key benefits I personally found helpful. And the first one is the ability to declare and maintain data table dependencies. We have the data pipeline observability and data lineage. We capture the origin of the data. And Delta Live tables are also be combined with great expectations, meaning that we can perform data quality checks using Python decorators or SQL constraints on streaming data. And, the official documentation has a comparison between structured streaming pipelines and DLT pipelines. As you can see, they both tick all the boxes. Well, the difference is when it comes to data flow orchestration. The Delta Live table pipelines have automated data flow orchestration, automated data quality checks and assurance, and automated error handling and failure recovery, automated CI/CD and version control. And when it comes to compute autoscaling, it's enhanced compared to structured streaming pipelines, which is basic. Okay, so again, we can use structured streaming and achieve the same results, right? Yes, but this is like reinventing the wheel when Databricks has already done that for us. It will save a lot of time. We don't have to do manual jobs. We can build data pipelines, robust data pipelines, pretty quickly using Delta Live tables. Okay, so we have Delta Live tables, which is an amazing framework, and it saves us a lot of time, and we can perform data quality checks quite fast. And yeah, everything is perfect, right? Where is the catch? Well, the catch here is when it comes to pricing, Delta Live table pipelines usually cost twice as much as structured streaming pipelines. So that means you need to be able to decide when to use Delta live table pipelines. And this is up for you to decide if Delta live table pipelines would help your team, your business, and if it's necessary to use. Now, let's see a demo of this whole concept. What we are going to do here is we are going to use a Raspberry Pi simulator provided by Microsoft. It's free, so everyone can access the website. And we are going to generate some dummy data. We are going to send this streaming data to an Azure IoT hub. And on Databricks, we are going to use Delta Live tables and consume the streaming data from Azure IoT hub and build a whole Delta Lake, the bronze layer, the silver layer, and the gold layer in one go using one notebook. Now, bear in mind here that we are going to generate fictitious data with no business meaning, no business logic at all. So the purpose of this demo is actually to demonstrate Delta Live tables from a practical and technical perspective. So let's move to Databricks workspace here. Let me switch screens. Give me a second. Okay, hopefully you can see my screen. So before actually we move to Databricks workspace, let's take a quick look on the Raspberry Pi simulator. This is the website. So if you Google it, Raspberry Pi web simulator, you will find it. And it comes with a default script. If I click on the reset button here, this is the default script. The only thing that you have to do here is actually provide a connection string to your IoT hub. That's it. And then you can click the run button. It will start sending dummy data, message ID, device ID, temperature, humidity. Now, how can you find this? Actually, let me revert back to my script. And the only change I made here is actually add a few more columns, right? A few more columns, because actually what we want to do on the bronze layer is to split the data set into two data sets. So I needed more data, that's it. I have device ID, temperature, humidity, wind speed, wind direction, RPM, and angle here. Dummy data, just generate some dummy data. And for connection string, how can you find this connection string? You go into your IoT hub. I have already set up my IoT hub here. If you go under devices, so click on the devices blade, you create a device, you click on the device, and then here you have the connection string. So you copy that and you paste it here. And then you click the run button and it starts sending data. So as you can see, it will start sending message ID 2, message device ID, temperature, humidity, wind speed, wind direction, RPM, and angle. Start sending data to your IoT device. Now, if you want to make sure that you've been receiving the data in your IoT hub, you go into the overview tab, you scroll down, you check the data for the last hour. Usually it takes a few minutes the first time, and then you will see a spike. That means that you've been receiving the data successfully. So, okay, we do receive the data from the simulator here, right? The next step is to go to our Databricks environment. Now, in our Databricks environment, I have a few scripts here. The first one that we are going to see is this one, right? So this is the notebook that we are going to use to build a Delta live table pipeline. It is just one notebook that will do all the job in one go. And when if we want to use Delta live table and in Python, because we can use either Python or SQL, which is amazing. And if we use Python, the first thing we need to do is to import the Delta Live Table pipeline library, sorry, and then import the SQL types and the SQL functions. And then we need to start consuming data from the Azure IoT Hub. How can we do that? We have to provide the namespace, the name, the access key name, the access key value, the connection string. So all those data here form our connection string. And then we provide the connection string here to our Kafka consumer. When we are using IoT Hub, we need to use Kafka consumer. So where can you find this data now? If you ask me that, the answer is you go back to your Azure IoT device and actually scroll down to built-in endpoints. So click on the blade where it says built-in endpoints. You can find the Event Hub compatible name, the consumer group, the shared access policy, the Event Hub compatible endpoint. So using all those data here, you can populate the parameters here. And then you can start consuming data from your IoT device. We provide the payload schema, which is message ID, device ID, temperature, humidity, wind speed, wind direction, RPM, and angle. And here is where the magic happens. This is where we create our first Delta Live table. So here, using the Python decorator at dlt.createTable, we can provide a comment, we can provide a name for the table, we can provide table properties. Here I just provided a comment, nothing else. If you don't provide a name, the name of the Delta Live table would be the name of the function. So here we define a function called bronze turbine T, and that would be the name of the table as well that we are going to create in our Hive metastore. Inside this function, we are going to have a return statement that is going to read the data from Azure IoT Hub. So how can we read the data from Azure IoT Hub? We have to use spark.readstream.format, Kafka format. When we are using Event Hub, you have to, the format would be Event Hub. If you're using IoT Hub, the format would be Kafka. We pass the options that we provided here, right? We pass the options and then we load the data. The first thing we have to do is actually cast the value column into string, provide the schema, and then flatten out the value column so we can get the data later on using from_JSON. And we also create a new column with the current timestamp. At the end, we select the data we want. Here we want for the turbine data, we want message ID, device ID, RPM, angle, and timestamp. So this would create a table and it will just store the data that we receive from the IoT Hub into the bronze turbine T table. As we said, we are going to split the dataset into two tables, and the next one on the bronze layer would be a table called bronze weather T. And we are doing exactly the same thing, but using selecting different columns. Here we are going to select temperature, humidity, wind speed, wind direction. Those two columns here, message ID and device ID, as you can see, they are the same in both datasets because they will be used as a key to join the datasets later on. Okay, so we create the bronze layer, which is nothing but consuming data from the IoT Hub and storing the data without performing any changes, right? That's what the Medallion architecture recommends. Now, on the silver layer, we are going to create a table called silver turbine T table, and we are going to apply data quality checks. Here, again, we're using dlt.table to create a DLT table, and then we can use dlt.expect_or_drop, which is to use the great expectations to apply data quality rules. We can use expect or drop, expect or fail. There are other options too. I think we have warnings, drop or fail. You can pass multiple data quality constraints in a dictionary using expect all, and then you pass the dictionary with the data quality checks you want. So there are all those things that you can find on the documentation. And here what we are going to do is use expect or drop where the average angle is not null. So if the average angle is null, then this record is invalid. It will never reach the target table, the silver turbine T table here. If we use expect or fail, and we check that the average RPM is greater than 0, so if this condition is not correct, if the average RPM is less or equals to 0, then the whole pipeline will fail. So that's the difference between those two. And on the return statement here, we are going to read the delta life table that we created on the bronze layer up here, right? This table here. We are going to read from this table using dlt.readStream, and this is how you can read. You can create a streaming delta life table. That's how you read from a delta life table, and you create a streaming delta life table using .readStream. You read from the bronze table, and here, as we mentioned, aside from data quality checks that we are performing on the silver layer, we can also perform transformations. We can cast a column, we can rename columns. Here, as we mentioned, aggregates should not happen on the silver layer. Usually the aggregations happen on the gold layer. But for the sake of this example, I performed an aggregation here. And apologies about that. And then we group by the data. We are finding the average RPM and the average angle. And we are grouping by the data by device ID. And we are using the window function based on the timestamp column for 5 seconds interval. And we are selecting device ID, average RPM, and average angle. Now, one thing to notice here is that the expectations, the data quality constraints, are being applied on the transformed data. Here, when we have performed all the transformations, on the columns we have selected at the end, not on the original data. Just something to bear in mind. And we are doing the same thing for the silver layer, for the silver weather T dataset. Again, we are using the bronze weather T as a source, dlt.readStream. We filter the data where wind direction equals left. We are grouping by device ID and wind direction, again based on the timestamp column for 5 seconds interval, and we calculate the average temperature, average humidity, average wind speed, and we're selecting those columns. And on the gold layer, here is we are performing a join. Now, as you can see, the difference here is we are using dlt.read and not .readStream. When you use .readStream, that means the table would be a streaming table. If we use .read, that means that the table would be a materialized view. So, and the reason it is recommended to use materialized views on the gold layer is because we have streaming data. So we don't know when the data source is going to stop sending data. We don't know where the data will end. And that's why it's recommended to use materialized views and refresh the materialized views as frequently as possible, as we want anyway. So we are going to read from the silver turbine T table and the weather table as well from the silver layer. And we're performing a join here based on device ID, a simple inner join, and just filter the average temperature different to 5. Nothing complicated apparently. This is this is just a demo to demonstrate how you can build a Delta Lake using one notebook. Apparently, it's a very simple case here, right? So we have this notebook, and this notebook will be used to build our Delta Lake, but we cannot actually use an interactive cluster here to build this Delta Lake, to run this notebook here. We can't do that. What we have to do is actually scroll down here where it says Delta Life Tables. And here we need to click on Create Pipeline. We have to provide a name, let's say test pipeline name. We have the product edition, Core, Pro, or Advanced. You have the pipeline mode, trigger or continuous. If you want for it to run it forever, you use continuous, but then you have to stop it at some point. Yeah, and then you have to specify the source code. And here you go into your notebook, you specify the notebook, let's say this one. And then you can specify the destination as well, Hive Metastore or Unity Catalog. We can specify the storage location. We can specify the target schema. For example, here we can specify the target schema should be an example. We have the cluster policy here, the cluster mode, enhanced autoscaling, legacy autoscaling, fixed size. I'm going to use fixed size in our case and use only the driver node because it's a small pipeline. We don't need worker nodes as well. You can add notifications, add configuration, key value pairs here. You can see the channel, the worker type, and the driver type. I'm not going to create a pipeline because I have already done that. So if we go here, and I have already run it once. So first of all, we have two modes, development mode and production mode. Right now, we're using development mode because in production mode, we have automatic retries and cluster restarts. This is apparently used for production. If you click on settings, then we can change the pipeline mode to continuous, and we can click on save and start. And this will take a couple of minutes to start in order to find the resources. Here, I think we've been sending data. Yeah. So let's wait for the pipeline to run, and we will see the data flowing from one table to another. In the meantime, actually, we can go back to our workspace and see the same Delta Live table pipeline using SQL. I do like SQL myself, so if you're an SQL fan, you can use SQL. The only difference here is that I replicate the bronze tables using create or refresh live table here, because actually when you use SQL, you cannot consume data from IoT Hub. At least I haven't found a way. Now, if you use create or refresh live table, that means you are creating a materialized view. So we are replicating the bronze tables, but then the next step is exactly the same that we did using Python. We use create or refresh streaming table. That's why it's a streaming table here. We apply the data quality constraints that we want. So using constraint name, expect, you provide the condition, and on violation drop row or on violation fail update. And then we perform an aggregation here. We calculate the device, the average RPM, the average angle. We are casting the column we want. We rename the columns. And here, one thing to notice is in the select statement, we are selecting from using the stream keyword here and then open brackets live dot the table, the Delta Live table we want. And we are grouping by device ID and the timestamp column. So we are doing exactly the same thing that we did in Python, but using SQL. On the gold layer, again, we are performing a simple inner join based on device ID, and we're applying filtering as well. That's for you if you like SQL and you prefer building pipelines using SQL. We have this option here. Let's go back to our Delta Live table and see. I'm still waiting for resources. So give it a couple of minutes. And actually, since we are waiting, let's see the next notebook, which is this one. So remember that that we used, actually, let me clear the cell output. Remember that we said that one of the benefits of using Delta Live tables is that we can combine it with change data feed. Well, this is the case here. When we are using Delta Live tables, by default, change data feed is enabled. But if you want to enable change data feed on a cluster level, you can use this command here. or if you want to enable change data fit on a table level, you use this alter command to specify the table name, set table properties, and you enable change data fit to true. So then we're going to see some of the data that we inserted on the bronze table. And we are going to see how we can use change data feed. But we have to wait for the Delta Life table to start. It's taking a few minutes the first time. Give it a few seconds. Okay. Yeah, the first time it takes a few minutes, unfortunately. So you can see the source code here that points to your pipeline, to your notebook here. Update details, have waiting for resources. Okay. Actually, in the meantime, let me spin up my interactive cluster because that will take time as well. Yep. Okay. I guess. Oh, okay. Initializing. Let's see. Setting up tables. Yeah, we are close. Yep. So here, now as you can see, it's running. And I think, yeah, we are sending data. So we expect to see data in a few seconds. As you can see here, we have streaming table. Yep, we already inserted 134. Yeah, keeps we keep inserting new records here on the bronze layer, as you can see in real time. And you can see this is you can see the dependency between the tables. So from the bronze layer, then it goes to the silver layer, to the exact table that the data goes. So you can see the origin of your data. You can track your data backwards if you want. Right now, it's apologies. We are running the bronze layer. Now the serial layer is running as well, as you can see now. We have records on the serial layer, and those are streaming tables because we defined them as streaming tables. But here, as you can see, this is a materialized use, and this is going to be refreshed, like every I think a couple of minutes, every couple of minutes or so. So these stream tables, as you can see, they are still running. The materialized view will be updated in a little bit. But we have already inserted records here. So we can stop the pipeline because it will keep run forever. It's on continuous mode. And and it's kind of expensive if you run it 24/7. So we have the details. If we click on here, we have the details of the table. This is a string table. It points to the code. That's the target table. You see the status, start time. You can see the data quality, how many records were written. You can see the schema and the flows here. If you have applied data quality rules, you can see the data quality rules here, and you can see how many how many records failed or dropped. None for now, so that's good. And you have all this information here for each table. And you can also, if you're using trigger mode, you can select the table, and you can select the table. You have this tab here where it says select tables to refresh. You can select the table you want to refresh, and then you just refresh it. You also have you can see the Delta Life table pipeline on a list, but I think using a graph it's much more preferable, right? And that's how we can actually create a Delta Lake from scratch with only a few lines of code. Let's see if our interactive cluster is up. No, we're still waiting for that. Yeah, it will take a few minutes. So, because what we're going to see is first, okay, yeah, it's up and running. Let's go to our Hive Metastore. Let's see some of our tables. We should have plenty of records now. Give it some time. That's our example schema. Let's see. We have the bronze turbine T table. We can see the sample data here. Yeah. Yep. We have message ID, device ID, RPM, angle, timestamp, and we have plenty of records. On the bronze layer, on the silver layer, let's see as well. After applying data quality rules, we have less records. And on the gold layer, I expect just a few records. Yeah, less records as well. So let's go back to, so we have built our Delta Lake. Let's go back to our notebook here, enable CDC demo. Let's describe the history of this table here. As you can see, we have 19 versions and all those added information here. Isolation level is blind append, engine info, etc., etc. So we have all this information, but the main thing to notice here is that we have 19 versions. So every time we update the data set, a new version is created, and this is when we're using Delta format, and this is why we are able to time travel between data versions or restore the data into a previous version, which is amazing, I think. And then we have describe extended, and we can see where the location is of this table here, and this is the location is in DBFS in this location, and the enable change data feed feature here is already enabled because by default Delta Live tables have already this feature enabled. Now let's see our data. Okay, I think we have plenty of data, 175. So let's insert one dummy record here, right? Let's insert one dummy record with this data. And then let's update also the records with device ID, set the angle to 50. So let's update those records. And then delete the records with device ID 2. I think we have device ID 2 somewhere, right? Yeah, we have. So, okay, let's delete those devices, those records with device ID 2. And then this is how to use the change data feed output using SQL. So you can select star from table changes, and here you specify the target table, and you can specify the starting version of the data. Remember, we have multiple versions of the data, and the ending version of the data if you want. So that's, you can specify from version 0 to 3 or from 0 onwards all the data. Or you can use the commit timestamp column and specify a time range. So if we select from the bronze turbine T table from version 0 onwards, let's see what we have. We will have all this extra information about the change type, the commit version, and the commit timestamp. Now, here, remember, we have one pre-image value that would be the angle before the update, and update post-image is the value after the update, right? So that's we have plenty of we updated plenty of records. That's why we have so many records here. And we can also see the deleted records here. These are the deleted records. So we can select from the change data feed output with all this valuable information, and we have the historical data. Now, if you want to use Python to do the same thing, you can use spark.readstream.format.delta, and you enable the read change data option to true. You select the starting version from 0 or whichever version you want, and the table name. And here you filter based on the change type. Let's say we want all the values before the update. We can run this command here. We want all the values after the update and the insertions, for example, or we want all the deleted values. So give it a second and we will see all the values here. Yeah, all the values before the update, all the values after the update, all the insertions, and the deleted values. Now, sorry about that. How can we use this? Let me stop the streaming queries. So how can we use this information using slowly changing dimension of type 2? Remember, one of the added bonuses of using Delta Live tables is that we can enable slowly changing dimension of type 2 to keep historical records and keep track of the history of the records. Now, from this change data feed output, we can select all the data we want, let's say device ID, RPM, angle, timestamp, and here we just rename this underscore change as underscore type to operation type. The commit version, we also rename that, and the timestamp. And we select from version 0, and we are going to create a temporary table called temp bronze. Now, we are renaming those columns because under the hood, slowly changing dimension type 2 uses those columns, so it will create a problem if you have the same column names. But so you rename those columns and you create a temporary table. Now, if we go back to our scripts, and this is the script of how you can apply slowly changing dimension of type 2 using Python. Now, you can use the Python decorator dlt.apply changes, and here within those lines, you just apply slowly changing dimension of type 2. You know, and that's it. It's very easy. And you have to specify the target table and the source table. Now, both of them need to be streaming tables. And that's why here we read from the bronze table that we just created using spark.readstream, and we create a streaming table here. And also we create an empty streaming target table. And here, that's what we give as a target, what we give as a source. We specify the key, device ID, the sequence, that would be the commit timestamp, apply as deletes, the operation type should be equals to delete, and the columns to exclude are RPM and operation type. And here is the magic, we store the data as slowly changing dimension of type 2. And yes, because we are using DLT library, then we cannot run it with an interactive cluster. We have to go back here to our Delta Live table pipelines. Let me delete this pipeline because I'm using a free tier Databricks version. That means I reached the quota, the compute quota, and I have to open a ticket to Databricks. So I will do that another time. Let's specify our notebook here and select target schema, example, fixed size, 0 workers. Yeah, and I think we are good to go. Let's start this pipeline as well because it will take a bit as well. And if we go back to our Hive metastore, let's check the temp bronze table. This is actually the change data feed output that reflects all the changes. We have all the changes here, and the operation type, the version, and the commit timestamp. And using those columns, we are going to apply now slowly changing dimension of type 2 and create a new table with all the historical data, and you will see just in a few seconds when this pipeline runs. It will actually take a few minutes again, I think. In the meantime, you can see how you can apply slowly changing dimension of type 2 using SQL. Exactly the same thing. We create an empty streaming target table, and we use apply changes into live. That's the target table that we created here. From stream, example, temporary bronze, the temporary table that we created. For keys, we apply device ID, apply as delete when operation type equals delete, sequence, commit timestamp, the columns to accept, stored as slowly changing dimension of type 2. So this is how you can use SQL instead of Python if you are an SQL fan. Let's see if we have here anything. Initializing, it will take just a few seconds more. Setting up the tables, it could be just one run in one go. We could be fine. Okay, you can see it's loading. This is running, so let's see. Let's wait a few seconds. Yeah. We are loading the target table now. Okay, I think we are good to go. So if you go back to our Hive metastore and see, we have the target slowly changing dimension of type 2. As you can see, we have underscore start at and end at, which by default they are generated because we are using slowly changing dimension of type 2, right? So if you can see now, we are able to see that this record with device ID 0 had this value for angle between this timestamp and this timestamp. The same for this value here, and we have it was valid between this time range, right? But for here, this one is the latest version of device ID 0. So that's why this record is open. Entered is null because this record is open, and this is the latest version of the data. I think here for device ID 2, yeah, the record is not open because we deleted the record, so there is no current version of the data. This record has been deleted, but you can see the history of this record and when it was valid and what happened in the past. And business users typically like these kind of things because they are able to query between certain time ranges and know which is the current value of this record, what was the previous value, etc., etc. Now, when you apply slowly changing dimensions in Delta Live tables, this table is also automatically generated it has a lot of data as well and some added columns. Although the documentation says that you should not use this table, it's not stable. They keep fixing things. So you should only use the target table that you just created. You can find more information about Delta Live tables on the documentation. You will see about slowly changing the dimension of type 1 and type 2. You can play around. I think it makes things pretty easy to apply slowly changing dimension using Delta Live tables, and we don't have to write complex merge statements. And I think that was lacking from Databricks, and that now has been fixed using this Delta Live table framework. I'm not going to run the same pipeline using SQL, but I think you get the point. You scroll down here to Delta Live tables, you create a new pipeline, and then you are able to see your pipeline running and the data moving from one table to another. You can see the data lineage here and all, the data quality rules and all these kind of things. I think it's a very useful framework if you ask me. Now, apparently it's not cheap, so you bear that in mind. But it solves a lot of problems because it saves a lot of time for us to perform quality checks manually. We have data lineage, also very important, and things like that. I will post the GitHub repo that has all those SQL and Python scripts on the chat. So if you want to have a look and play around, as you can see, everything is free here. The Raspberry Pi simulator is free. You just set up a Azure IoT Hub, and it's pretty easy to replicate what we did here and play around and see what this is about. Okay, so let's go back to the slides. Let me switch screens. So, any questions?
Any questions? Thank you very much for this presentation. I hope that our audience enjoyed it as much as I did. So we already see a question here. When should you use data live tables, Apostole?
Well, I think Delta Live tables would be very beneficial when you have streaming workloads. You can use Delta Live tables, of course, to load files, to get to load the data from a database, but it wouldn't benefit as much considering the fact that it's an expensive framework. But in general, Delta Live tables as a framework shines when we have streaming data and streaming workloads.
Okay. Thank you for this answer. I see we have some questions, but let's keep our time. So thank you very much, Apostole, for this excellent presentation. So also thank you everyone for joining our session today. If you enjoyed this event, please join the DataZen Greece community to be notified about all our upcoming events and updates. We have many things coming up. Also, if you would like to be a speaker in one of our next events, please feel free to connect with us as well. And you should definitely join DataZen Greece community if you want to share experiences, gain knowledge in data analytics, get acquainted with new technologies, or realize business value from your data products. Also, as you can see in our final slide, please consider subscribing to our sister community, Delivery Management in Greece, if you're interested to learn more and contribute to topics like delivery management, project management, and agile practices. Thank you very much, everyone, for joining. Have an excellent rest of the day. Thank you.